there is an object sitting somewhere near you right now. Maybe on your refrigerator, maybe inside the phone in your pocket, maybe in the headphones resting around your neck, and it is doing something that no one in the history of human civilization has ever fully explained in a way that satisfies a curious mind. Not philosophers, not engineers, not Nobel Prize winners. It is pulling metal toward itself through empty space without touching it, without burning fuel, without any visible mechanism at all. And when you ask a physicist, a real one, not a textbook, why that happens, if they're being completely honest with you, they will pause. And then they will say something that sounds almost like a confession. That object is a magnet, and the confession is this: we do not explain magnetism the way you think we do. Now, before you assume this is going to be one of those videos that waves its hands and says, quantum weirdness, nobody understands it, moving on, it is not, because there is actually a real answer, a deep one that connects magnetism to time, to space, to the speed of light, and to a principle so fundamental that once you understand it, you will never look at reality the same way again. The answer involves no magic, but it will feel like magic, because the truth turns out to be stranger and more beautiful than the mystery. Here is the idea this entire video is built around, and it will take 20 minutes to really feel its weight. Reality is not built from things, it is built from limits, and what we call mysterious forces, magnetism included, are almost always just limits in disguise. Hold that thought. We are going to earn it. Start with the refrigerator magnet. You press it against the surface. You let go. It stays. Your intuition has been trained to accept this without question because you have seen it your whole life. But notice how your intuition expects something. It expects a reason. It expects a mechanism, a string, a glue, a hand. And when none appears, your brain quietly files the whole thing under "that's just how magnets," and moves on. That is not understanding. That is surrender dressed up as familiarity. So, let us actually ask the question properly. What is happening between that magnet and the refrigerator door? The first answer you probably learned goes something like this. Magnets have a north pole and a south pole. Opposite poles attract like poles repel. And there is something called a magnetic field filling the space around them. That is the textbook version. And it is not wrong, it is just not an explanation. Saying a magnet attracts iron because of a magnetic field is like saying a fire burns because of a burning field. You have named the phenomenon and called it a cause. The field description tells you where the force acts and how strong it is. It does not tell you why the force exists at all. This is the first misconception worth clearing up. Most people, even science-educated people, believe that once you introduce the concept of a field, you have explained something. You have not. You have mapped something. Maps are useful, but a map of a city is not a reason the city was built. So what actually is a magnetic field? Where does it come from? Here's where the story takes its first real turn. It comes from electrons. Specifically, it comes from electrons moving, or more precisely, from a property of electrons called spin, which is one of the strangest words in all of physics, because electrons are not actually spinning, not in any sense you would recognize. Spin is a quantum property. It has no classical equivalent, and if anyone tells you they have a simple intuitive picture of what electron spin really is, they are oversimplifying. This is a simplified explanation to make the core idea intuitive. But the key point is that every electron behaves like a tiny magnet. It has its own magnetic moment. And in most materials, the electrons are arranged so that their little magnetic moments all cancel each other out. Point this way, point that way, randomized, balanced, net zero. But in certain materials, iron, nickel, cobalt, something extraordinary happens at the atomic level. The electrons in those atoms can align. Their tiny magnetic moments point in the same direction, and when you get trillions upon trillions of electrons all pointing the same way, their individual effects add up into something you can feel with your hand. That is a magnet. That is the whole trick. Pause and think about how strange that already is. A force you can hold in your fingers is just the accumulated whisper of subatomic particles, all pointing the same direction, the macroscopic world emerging from microscopic alignment. But this still does not answer the deepest question. Why do aligned electrons create a force across empty space? Why does pointing matter? This is where we need to talk about something most people have never heard, connected to magnets. We need to talk about Einstein, not the famous equation, not black holes. We need to talk about a consequence of special relativity that is so concrete, so verifiable, and so deeply weird that it changes the entire story of what magnetism is. Here is the setup. Imagine a wire carrying electric current. Inside that wire, electrons are moving, drifting, actually very slowly, just a few millimeters per second on average, though the signal itself travels near the speed of light. The wire is electrically neutral from the outside. The number of positive charges in the metal atoms equals the number of negative charges from the electrons. A proton sitting near this wire feels no force. The positive and negative effects balance perfectly. Now here is the question that changes everything. What does that same proton see if it is also moving in the same direction as the electrons in the wire? Pause and predict what happens next. The charges are balanced. The wire is neutral. The proton is moving alongside the electron. Nothing should change, right? Wrong. And this is where special relativity reaches down into everyday physics and quietly rewrites everything. When the proton moves alongside the electrons, something happens to distance. This is length contraction, one of the measurable, tested, real consequences of special relativity. Objects in motion are length contracted along the direction of travel from the perspective of a stationary observer. The electrons in the wire, from the moving proton's frame of reference, appear slightly more densely packed together. Not much. We are talking about an effect that requires enormous precision to measure in normal circumstances. But the positive charges in the wire, which are stationary, do not have this contraction. So, from the proton's perspective, the wire now has slightly more negative charge per unit length than positive charge. The wire looks electrically negative, and an electrically negative wire attracts a positive proton. What the proton experiences as an electric force, the proton is attracted to the wire, is what a stationary observer sees as a magnetic force. They are the same thing, viewed from different reference frames. This is the second misconception to destroy. Magnetism is not a separate force, standing alongside electricity in some fundamental lit. Magnetism is what electricity looks like when you change your velocity. It is electricity seen sideways through the lens of relativity. Electric and magnetic fields are not two things, they are one thing, and your state of motion determines which aspect of that thing you perceive. This is not a metaphor. This is not a simplification. James Clerk Maxwell described this mathematically in the 1860s, decades before Einstein, though he did not fully understand why. Einstein saw Maxwell's equations and realized they demanded a new understanding of space and time. Magnetism is woven into the fabric of special relativity. The force holding your refrigerator magnet to the door is, in a precise technical sense, a relativistic effect. Let that settle for a moment. The humble refrigerator magnet contains, encoded in its every pull, the same physics that explains why time slows down on a fast-moving spacecraft. The same geometry of space-time that makes GPS satellites require timing corrections to keep your maps accurate. Those satellites experience time differently because of their velocity and their altitude in Earth's gravity. And without relativistic corrections, their positioning would drift by several kilometers per day. That same framework is operating inside every magnet you have ever touched. This is what the core idea of this video is really about. You thought magnetism was mysterious, and it is. But the mystery is not random. The mystery has a shape, and the shape is a limit. The speed of light. The maximum speed at which information can travel through the universe. The hard ceiling written into the structure of reality itself. Magnetism is not magic peeking through a gap in physics. Magnetism is what physics looks like near that ceiling. Now here is the third misconception, and this one runs deep. People believe that scientists understand magnetism at the fundamental level, and that the only mystery is at the quantum level, where everything gets weird anyway. But there is a famous exchange, and I want to be careful here. I am not putting words in anyone's mouth. I am describing the spirit of an idea that has been expressed by physicists in various forms, where a brilliant mind was asked to explain what a magnetic field really is, fundamentally, why it exists, and the honest answer was, we can describe it perfectly. We can predict it with extraordinary precision. We can use it to build every electronic device on Earth, but explaining why the universe has this property at all, why moving charges create forces, why there is a thing called charge in the first place, that reaches down to bedrock questions that physics maps but does not yet answer. This distinction matters enormously. There is a difference between knowing how something behaves and knowing why it exists. Science is extraordinarily good at the first. The second is the frontier, and this brings us to quantum electrodynamics, which is the most precise scientific theory ever constructed. It predicts the behavior of electrons and photons, the particles of light, with an accuracy that, if you were measuring the distance from New York to Los Angeles, would be accurate to within a human hair's width. QED describes magnetism as the exchange of virtual photons between charged particles. The force between two electrons is, in this picture, mediated by particles of light being passed between them like an invisible game of catch. Virtual photons are not like regular photons. They exist in a strange mathematical sense that is very difficult to make physical sense of, and physicists are careful to note that virtual particle is a label for a term in a mathematical expansion, not necessarily a description of a real thing flickering in and out of existence. This is a simplified framing. The actual machinery of QED lives in mathematics that requires years to learn. But the key point is this: at the deepest level of our current description, magnetic force is transmitted at the speed of light. Photons travel at the speed of light. The limit, again. The ceiling, again. Every layer you dig into, you find the same fingerprint, limits. Here is a real-world anchor that ties this together in a way that feels almost impossible. Muons. These are particles similar to electrons but about 200 times heavier. They are created high in Earth's atmosphere when cosmic rays collide with air molecules. At that altitude, about 15 kilometers up, a muon is created and begins falling toward Earth at about 98% of the speed of light. Muons decay. Their half-life is about 2.2 microseconds. Simple arithmetic says a muon traveling at light speed for 2.2 microseconds only covers about 660 meters. It should not even come close to reaching the ground from 15 kilometers up. And yet muon detectors on the ground register them constantly. Why? Time dilation. Because the muon is traveling so fast, time passes more slowly for it from our reference frame. From the muon's perspective, the atmosphere is length contracted. The 15 kilometers becomes just a few hundred meters. Either way you frame it, the muon makes it to the ground. A particle's lifetime, its biological clock in us, is stretched by its velocity. This is not speculation. This is measured repeatedly with precision instrument. Time itself bends near the limit, and the force that holds your compass needle pointing north, the same force, the same relativistic structure, the same ceiling. Now here is the fourth misconception, perhaps the most pervasive one. People think that when physicists say they cannot explain something at the fundamental level, it means physics is broken or incomplete in some embarrassing way. But that is exactly backward. The fact that we can describe magnetism with perfect precision, trace it all the way down to quantum electrodynamics, connect it to special relativity, measure its effects to 15 decimal place, and then still acknowledge that the bedrock question of why charge exists at all remains open. That is not failure. That is the most honest thing science can do. The map is not the territory. Knowing the map exquisitely well is a triumph. Saying the territory still holds mystery is not a defeat. It is an invitation. Pause and predict what happens next in this story. We have traced magnetism to electrons, electrons to fields, fields to relativity, relativity to the speed of light. Where does the trail go when we ask what the speed of light really is? Here is the answer that most physics courses, save for graduate seminars, and most science videos skip entirely. The speed of light is not just a fact about light. It is a fact about causality, about information, about the structure of space-time itself. Light travels at that speed not because photons happen to be fast, but because the universe has a fundamental parameter, call it c, that governs the ratio between space and time, a ratio written into the geometry of reality before any particle, any force, any atom existed. Light travels at c because it has no mass. If it had any mass at all, any mass, it would travel slower. The speed of light is the speed of zero mass. It is what you would travel at if you had no resistance to acceleration at all. Everything slower than light has mass. Everything. Mass is what slows you down. Mass is your ticket to existing in time, to having a before and an after, to being a thing rather than a signal. And the forces that act between massive things, gravity, electromagnetism, the nuclear forces, are all constrained by that same ceiling. Nothing in the universe communicates faster than c. Force itself is communication. Force is the universe's way of one thing saying to another thing, I am here, adjust yourself accordingly, and that message travels at the speed of light. This is the fifth misconception to clear up. People imagine forces as invisible threads that connect objects. You move a magnet, the other magnet immediately knows, but that is not what happens. If you moved the sun out of its position right now, Earth would not feel the change in gravity, not for 8 minutes. The gravitational information would travel toward us at c. In the same way, magnetic field changes propagate at c. Force is not instantaneous. Force is a message, and all messages have a speed limit, which brings us back, finally, fully, to the question we started with. Why does the magnet stick to the refrigerator? The full answer, assembled now from everything we have built, the magnet sticks because its electrons are aligned. Aligned electrons produce a net magnetic field, which is actually the relativistic aspect of the electric field from those electrons, visible because of the electron's motion and spin. That field propagates through space at the speed of light, warping the geometry of electromagnetic potential around the metal door. The iron atoms in the door, which contain electrons free to align, respond to that field and develop their own temporary alignment. This is called induced magnetization. The two fields interact and the result is a net force pulling the surfaces together. That force is mediated by virtual photons. The whole structure, the alignment, the field, the interaction, the force, obeys the laws of special relativity because those laws are the laws of how information travels through space, and force is a form of information. A magnet sticks because aligned electrons broadcast a relativistic message at the speed of light, and the door listens. That is not a mystery. That is one of the most precisely understood phenomena in all of science. And it is also one of the most profound, because every layer of that explanation contains the same thread. The limit, the ceiling, the architecture of reality is not built from it is built from constraints. The speed of light is not just a fast speed. It is the seam where space and time are sewn together. Magnetism is not a magic force. It is what the seam looks like when you move. Here is the sixth misconception, a quiet one that lives in the background of how most people think about physics. There is a common assumption that the fundamental forces of nature are the real things, and the particles and fields are just how those forces happen to manifest. But the deeper you go, the more you find that forces are not fundamental in the way that assumption implies. What seems fundamental is the symmetry, the mathematical invariance, the conservation laws, the constraints. Force is almost like a consequence of the constraint, not the other way around. The electric force exists because the universe has a symmetry called gauge invariance. Gravity exists because the universe has a symmetry related to how objects move through curved space-time. The constraint is deeper than the force it produces, limits all the way down. One more real-world anchor before we close. The electricity running through your home right now. The current powering this screen, this speaker, this moment. Those electrons in the wire are moving at roughly 1 millimeter per second, slower than a sleepy snail. And yet the effect, the signal, the power, travels at close to the speed of light. Because the signal is not carried by individual electrons shuffling along, it is carried by the electromagnetic field propagating through the wire. The electrons nudge each other. The field does the work. Once again, the field, the relativistic aspect of moving charge, is doing something the particles alone could not do. The limit enables the technology. Without C, without relativity, without the seam in spacetime, you would not have electricity as a useful phenomenon at the human scale. Magnetism gave us motors. Motors gave us industry. Industry gave us the world you are living in. And buried under all of it is a relativistic effect so subtle that for most of human history, no one even knew it was there. Here is what to take from this. The next time something feels mysterious, not just in physics, but anywhere, ask a different question. Not what is this? Ask instead, what limit is this built on? What constraint is creating this appearance? What ceiling is the magic brushing up against? Because the history of science is not a history of finding answers and making mystery disappear. It is a history of finding that every answer reveals a deeper structure, and that structure is always some form of constraint. Time, space, energy, information. Reality is not a collection of things interacting freely. Reality is a set of rules so strict and so precise that the rules themselves create structure, create atoms, forces, fields, mountains, stars, and the magnet on your refrigerator. You have spent your whole life near magnets. You have used them in speakers and motors and hard drives and MRI machines that can see through bone. You have accepted them. You have never quite understood them. And now, if this has landed the way it was meant to, you do not just understand them, you feel them. You feel the relativistic shimmer in every little pull. You feel the speed of light encoded in the force. You feel the architecture behind the physics. The universe is not hiding its secrets behind a curtain. It is showing them to you at every scale, in every force, in every moment. And the secret, the same secret every single time, is this. Reality is not made of things. It is made of limits, and every limit is a door